thanks for joining me. We're going to go through some basics of nomenclature, and we'll start with a rather simple type called binary compounds that deal with a fixed oxidation state. So the word nomenclature simply means the process or the rules of naming something. And we're only going to be dealing with inorganic nomenclature. Organic nomenclature we may do at the very end of the school year. So all of these types of names and naming systems are relatively straightforward. What makes them sometimes challenging is the fact that I won't tell you which system you're looking at. You'll have to figure that out. So the first type we're going to look at is called binary compounds. The prefix bi means two, so this is referring to compounds that contain two different elements. Now, O2, oxygen might contain two atoms but does not contain two elements, so it would not be a binary compound. Now, SO2 does contain two elements. It does contain three atoms, one sulfur and two oxygen, but it's still considered a binary compound. So in order to use the rules I'm going to talk about now, the metal will have what's called a fixed oxidation state. That means it will be in group 1 and have a +1 charge. Group 2, an alkaline earth metal, a +2. Silver, group 11, just silver, is always +1. Zinc, group 12, is always +2, excuse me. And aluminum in group 13 is always +3. So if you have silver, zinc, aluminum, or an alkali metal or an alkaline earth metal, and a nonmetal, this is the system you will use. So to remind you of what I just said, if you are an alkali metal in group 1, you are always and only a +1 oxidation state. If you're an alkaline earth, group 2, you're always and only +2. The other three that are fixed are silver, zinc, and aluminum. They kind of go like a little stair step going up. Silver's +1, zinc +2, and aluminum +3. Aluminum you should already know because it has 3 valence electrons. It would like to lose all 3 to become isoelectronic to neon. And then the other 2 we simply memorize. Now this is a system you're actually kind of familiar with, although you may not be aware you are. It says to name these compounds, give the name of the metal, followed by the name of the nonmetal, drop the ending, and replace with the suffix IDE. So for example, NaCl, the metal is sodium, the nonmetal is chlorine, but I'm going to not leave it this way. I'm going to drop the ending and add the suffix IDE. So this is sodium chloride. It's made from a sodium 1+ ion and a chloride 1- ion. When a compound forms, it is neutral, meaning all the charge is balanced, or you have the same amount of positive and same amount of negative charge. Here's another one. Here's calcium, element 20, it's a fixed charge, and sulfur is element 16, it's a nonmetal. So this contains calcium and sulfur, but I'm going to drop the ending of the nonmetal and add the suffix IDE, calcium sulfide. It's made from the 2 ions, calcium 2+, because calcium's in group 2, it wants to lose 2 electrons, and sulfide 2-, it needs to gain 2 electrons to become isoelectronic to argon. And when that gets together, it will be neutral as well. Finally, let's look at this one, Ali3. Here's aluminum, fixed charge +3, and iodide is a -1 because it's a halogen, one away from xenon. So it contains aluminum and iodine, but that's not what I'm going to call it. I'm going to call it aluminum iodide to show that they're bonded together. And it's made from the aluminum ion 3+ and iodide ion 1-. Now notice if you put a 3+ and 1- together, this isn't neutral. It would have a 2+ charge. To make it neutral, we would need to have 3 iodides at 1- each to balance the 3+ charge of the aluminum. And then it is neutral. And that's what this shows in the formula. The subscript, the 3 after the I, refers to only what is immediately before it, which in this case is the I. So there's 3 iodide and 1 aluminum. That's all there is to naming binary compounds with a fixed charge metal. This one's simply showing if you have a metal like lithium, sodium, potassium, cesium, any of these metals here, you simply name the metal and then you say the word ion after. But if you have a binary compound and you have a nonmetal, notice the nonmetal ending all changes to IDE, right? Hydride, fluoride, chloride, bromide, iodide, oxide, sulfide. And that simply means it's the nonmetal by itself bonded to something else. Let's examine how we would go from a name into a formula. So let's start with aluminum chloride. Now, based on the ending of the name, it ends in IDE. That is my clue that I'm looking at a binary compound. So my first step is to write out the names with a space. Next, with the help of a periodic table, I'm going to write out the symbols and charges of each element. Aluminum is Al, chloride is Cl. Now, I know aluminum because I memorized it is always 3 plus. In chloride, element 17 is 1 away from the noble gases, so all halogens are 1 minus. Now at this point, I can use one of two methods. I could use what I call the thinking method, or I can do the criss-cross rule. The thinking method says, what number do 3 and 1 have in common? And the answer is 3. So that means I need 3 positive charges and 1 negative charge. Well, I already have 3 positives if I have 1 aluminum, but in order to get 3 negatives, I would need to have 3 Cls. So that would tell me the formula is going to be AlCl3. Now, that would be the thinking method. The crisscross method said simply take the superscript, this number up here for aluminum, and make it the subscript for the chlorine, and make the superscript for the chlorine the subscript for the aluminum. So it's kind of like square dancing where you swing your partner round and round, but this time we're going to flush it down. So the 3's going down here and the 1's going down here. So here it goes. Crisscross charges as subscripts. So this 3, swing your partner round and round, flush it down, ends up down there, and the 1 ends up down with the aluminum. Now, 1's don't have to be written, they're understood. So our final answer is going to be AlCl3, and that is the formula for aluminum chloride. It's that simple. Now, if I'm looking at this, hopefully you would be able to figure out if there's 1 Al and 3 Cls, that the gray atom in the center must be the aluminum, and the green guys must be the 3 Cls in that molecule. Again, this is just showing what we looked at. Write the names, write the charges, crisscross the charges, and then you get your final formula. Now, the mistakes that some people make is they include charges in the final formula. There are no positive or negative charges in the final formula. It's all just numbers only, and ones are never written. Also, sometimes I'll see people put this coefficient, this 3 subscript as a coefficient in front of the Cl. That's also not how we write it. It's going to be AlCl subscript 3. All right, let's try another one. Here's magnesium oxide. Magnesium oxide, magnesium is an alkaline earth metal, and all alkaline earth metals have a 2 plus charge. So look at what I've done here. I've written the name, I spread it out, I put the symbol magnesium Mg, the symbol for oxygen O. Then I figured out the charge of magnesium must be 2 plus because it's in group 2. Oxygen is minus 2 because it's 2 away from the noble gases. Now, if you get the same charges for both of the ions, you can go directly to step 5 and just put those together. Okay? If you didn't recognize they have the same charge, then go ahead and do the crisscross. The 2 comes down here. The 2 from the magnesium comes down for the subscript after the oxygen, and you write MgO2. But you have to remember, these always get reduced to lowest terms. All right, let's see how we're doing here, give you some practice. So we want to try to name these. So remember, if you have a binary compound, a metal with a fixed charge, and a nonmetal, name the metal. This is barium, it's element 56, and oxygen, but we're not going to call it barium oxygen. We're going to call it barium oxide. On the next example, sodium is element 11. It is Na1 plus, and the ending here, IDE, is telling me it's a binary, so this must be bromine. Bromine is a halogen, it's a -1, so if you have a +1 and a -1, they get directly together, NaBr. On the next example, I have magnesium, an alkaline earth metal, fixed charge, and a nonmetal, iodine. I'm not going to call it magnesium iodine, but instead magnesium iodide. On number 4, I have potassium, an alkali metal, and chlorine, a nonmetal. It's not going to be potassium chlorine, but what's it going to be? You got it, potassium chloride. Strontium is an element with a 2 plus charge. It's an alkaline earth metal. This ends in IDE, so it's a binary compound. Fluorine is a halogen, -1. So if I have a 2 plus and a -1, the 2 goes down after the fluorine, the 1 goes with the strontium. So how about SrF2? And finally, cesium fluoride. Cesium is, I believe, element 55. It's a 1 plus. Fluoride's a 1 minus, so they get directly together, CSF. And that's how we do naming of binary compounds where the metal has a fixed charge. All right, what you might want to do for practice is pull up the sheet ions and chemical compounds. And what it will have you do is crisscross. So you got some positive ions here on the left going down, and you got some negative ions going across. And when we're looking at the top, for right now, I only want you to crisscross the chloride, the sulfide right now, just for practice. We're going to deal with these other things, the hydroxide, the nitrate, the sulfate, carbonate, phosphate. Those are called polyatomic ions, and we'll address those in our next lesson. All right, thanks for joining me. Have a good day. Bye-bye.